So we're going to look at a set of data. Oh, wait, forgot. Okay, this also got jacked up. So you're going to have to make some new graphs. So this one's okay, but this is what it should really look like. So go ahead and make some rough sketches of those. I'll leave that up there. You can just use your drawing tools. So the normal distribution is symmetric and shaped like a bell. The one that tails off to the right is called skewed to the right or positively skewed. The one that tailed off to the left is the one that got cut off. So you're going to have to draw that. So use your fingy and make a couple of those pictures. So I'll leave that up there for a second. I'm just going to pause. Just give me 1 second. I don't remember how to pause on the other screen. So now we have a set of data. So I converted the numbers into a table. You don't have to make it into a table. And we're going to make a histogram. We're going to take our time with this. Make a horizontal line. So I'm going to use the shapes tool. I'm going to use the line tool. I'm going to make a horizontal line. So it gives me plenty of space. So there should be lots of white space up here. Hold the shift key down. Horizontal line. And then we're putting the numbers from 31 to 37 in a text box below it. So 31, tab, 32, tab, 33, tab, 34, tab, 35, tab, 36, tab, 37. And I don't need to go anymore. And I'm just going to center it. I don't really care if you do it or not. Okay. And then it gets real technical. Ready? I'm going to use the drawing tool. How many 31s do you see? I make one X.
No, it's not. Only
technical. So technical, I know. So for 32, how many 32s are there?
2.
So I make 2 X's. Now the tricky part is I need to make the X's about the same size. So not like one big X and tiny little bitty X. Okay. Next X should be about the same size. And then 1 X. And then 4 X's. 1, 2, 3, 4. And then 2. And then 3. And then 1. Okay. Now we'll get just a little fine motor skills here. Go back to the shapes tool. Change it from line to a rectangle. And we're going to make a rectangle around our X's. So start on the top left corner and drag it down. Oh, just one. I have too many there. Okay. Drag it down to the left. And then top left corner again. And a histogram is basically a series of rectangles. They should be touching, but if they don't perfectly touch, that's fine. And the heights are based on the number of X's. Okay. Again, we're going to start up high, right towards the top of the X. Doesn't have to be exactly perfect. Whoa, hello. My hand slipped, apparently. Whee. And then we got 2 X's. And then 3 X's. And this used to be a smartboard, so some of this stuff was hidden. But if you scroll down a little bit, you can see that this should be... Oh, it doesn't say it. I thought it must be the other one. Okay, so at this point, go to the drawing tool. I'm going to choose black. We go through basically the middle of the highest boxes. So these two towards the middle, we're going to ignore these. So go through the top and then down. So this is more or less normally distributed. We have about the same number of boxes on the right and on the left. So this would be considered a normally distributed graph. When you're done that one, next one you're going to do on your lonesome. You don't have to make the frequency distribution chart. Just count the numbers. So I'm going to give you a few minutes, finish this one up, and then start the next one. Moving on. So again, we're going to make a horizontal line below. We're only going from 11 to 15 this time. So you probably should spread out the numbers a little bit more. There's fewer numbers. So hold the shift key down to make that horizontal line. Text box underneath. So 11, tab, tab, tab. 12, tab, tab, tab. 13, tab, tab, tab. 14, Tap, 15. Okay. Start with my 11s. I have 111. So I put one little X here. I have 112. Put one little X here. I've got 1, 2, 3 13s, so 3 little X's. I've got 1, 2, 3, 4 14s, so 4 X's. And I've got 1, 2, 3 15s. And then I would just double check to make sure I've covered everything. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and I should have that many X's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. At this point, in the interest of time, I'm not even going to make my histogram. I'm just going to start at the top of the X's. So it comes up, and this tails to the left. Therefore, it is negatively skewed as it goes to the left. Because the preponderance of your data is on the right. Questions? This ain't that hard, is it? Okay. Will it get harder? Yes, because the other stuff's going to have more to do with it underneath. All right. This got all wickety-wackety. So let me show you the one it should be using. Oh, that's not it. Oh, that's not it. There we go. So that should be the table. So use that table. I'll leave that up there for a sec. Let me just pause our screencast. So we had a normally distributed, we had a negatively skewed, this one's positively skewed. Let's see what's next. What's next is some examples, okay? So where are most of the numbers here? On the right, so it's going to be negatively skewed. And on this one, pretty evenly distributed. So that is normally distributed. And then now it's time to talk about this thing called the empirical rule, okay? So you have the mean in the middle, and we move away one standard deviation. So all that means is 34% of your data will be in that first little mark. And then 13.5% of the data, and then 2, and then 0.5. And the numbers are rounded off to make arithmetic a little easier for you. So as far as you're concerned in this class, those are the numbers we're going to work with. If you take a statistics class, and I think some of you are signed up for next year, the numbers might change by a couple of decimal points. Okay. So we add to the right and subtract from the left, just like you do on a regular number line. So 68% of the values are within one standard deviation because I got 34 and 34. And then 95% are within 2 because I already had that 68 plus 13.5 twice. 27 plus 68 is 95. And then 99% of your values are 3 standard deviations away because we got the 95% and we got the 2 and the 2. 6 sigmas. There's actually a group of people. They're called the 6 Sigma, ready? Ninjas. Okay. These are people who work in business who teach businesses how to be more efficient. How efficient? 99%. That's what the 6 Sigma is. Okay. So they teach them how to look at their processes, how to work with the people in their corporation, and teach them how to work most efficiently so people are working together in harmony and making sure that they get their work done. So if they have people have redundant jobs, well, somebody gets reassigned or fired. Okay. Or if they have people in different departments, and I happened to work for a corporation for a few years, and I knew people in my building, there were 800 people in my building, I knew about 100 of them because other people were doing different things. And what they do is they look at the entire corporation and they see if people are doing complementary jobs or redundant jobs. So if Logan's working in one department, if Barbara's working in another department working on a complementary job, they might suggest, hey, these 2 people should be working together because they're working on similar projects, but they're doing different things. So a 6 Sigma ninja usually has a college degree and a couple certifications, and they're paid really well.
How much?
Like thousands of dollars a day. because they come in to kind of figure out how if a company's worth a few million or a few $1 billion, spending a few $1,000s to make themselves more efficient, it's worth their time. Usually they're project managers, and a project manager is just that. They manage a project. They make sure that all the team members on the project are doing their job and keeping up with what are called deadlines. Okay? All right. We're going to make this much simpler. We're just talking about the numbers. So we have a normally distributed data. So underneath, make a text box. Actually, before we make the text box, let's just start with the 66. Okay. So off to the side, I'm just going to use a drawing tool. How many sigmas are we going? 6. 3 to the right and 3 to the left. So we're going to do 66 plus 11. That's 77 plus 11 more. That's 88. How many more do I need? How many more 11s? 1 to the right. And then I do the same thing to the left. So 66 minus 11 is 55. Minus 11 again, 44. Minus 11 again is 33. So now we're going to take our text box and we're going to start from the least to the highest. 33 goes right here underneath that first tick mark. Then keep tabbing over until you get to the next one. Tab over. 5, tab over. 66, which is our mean. You might have to use the space bar a little bit. Tab, tab. 77. Tab, tab, tab. 88. And then last but not least. Okay. And now we're going to answer questions. The numbers are always going to be the same. So let's just put the numbers in here. So this first one is 0.5%. This next one is 2%. The next one, I'm going to start using my text box. That's 13.5%. And my next one up here, these are both the same. These are 34%. And this is also in the other slide. But let's just go ahead and put them right here too. And then this 13.5%, hey, I can copy and paste. It'll let me. It's not going to let me. This big screen does not like it when I try copying and pasting text boxes sometimes. And then again, I have my 2% here. And I got my 0.5% here right there. And now I am ready to answer all the questions. So the first question says, what's the probability of being less than 44? So I take a look and I'm looking for numbers that are less than 44. So that's the 2%. So that's going to be 2.5. Okay. Let's make text box. 2.5%. So I just add up the areas. Probability greater than 77. Hey, Jerry. So let's see. That's going to be the 13.5 and the 2 and the 0.5. So 13.5 plus 2 is 15.5. And then plus another half is 16. You want to get Jerry up to speed? And the last one's between 55 and 88. So that's this one, and that's this one. So 34 times 2 plus 13.5. So 34% times 2 plus 13.5. So 13.5 added to 68 is 81.5%. So it's always going to be a percent less than 100. You got something bigger than 100, y'all did something wrong. That's it. That's all there is to it. My thumbs. And I just got to practice a little bit. So take a look at the next page. See what you can do. And then we'll talk again in a few minutes. I'm going to do it up here while you all do it down there. So I got 34 minus 5 3 times. 34 plus 5 3 times. That looks like a 6. 34 is the middle. Once I have my 6 numbers, including my 7th, which is my mean, put them in the text box, start in the far left. Smallest number, and just keep, basically I can just keep adding 5s. You look at that first one, that's a lot of numbers to add. There's actually a quicker way to get the answer, but you can add up all those numbers if you want. Okay? Because remember, we're looking at everything greater than 24. So that's this one, and 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 this one. That's a lot.
So just subtract
You could just subtract from 100%.
100.
Okay?
So it's
So 100% minus the 2 ones at the beginning. So 100% minus, well, that's
2
2, and that's a half, so minus 2.5.
so 90.
97.5%. So I don't care which way you do it. You can do it either way. But in this case, I think it's a little easier to add 2 things and subtract from 100 than add 1, 2, 3, 4, 5, 6 of them. All right. Find the probability. Hey, didn't we just do that? That was a 2.5. So 2.5%. The probability is between 24 and 44. So that's this one, and this one, and this one, and this one. Ooh, I love symmetry. So 34 times 2, 13.5 times 2, and add them together. Or you can remember that if I have 2 standard deviations away from either side, that is 95% of my data. But if you don't remember that, then just go ahead and do the arithmetic. So remember, that's 13.5 times 2 plus 34 times 2. And if I don't want to do that work in my head, I can always copy and paste. Notice I did not put the percentages in, because if you put the percentages in, Desmos doesn't like it. And there's my 95. Okay, so equals 95%. A minute or two, look that one up. And then look on the next page, because they don't give you some stuff. Is right here. They tell me, whoopsies, I didn't want to use that one. They tell me that 68% of the packages fall between 22 and 24. So that's 34 here and 34 here. So that means I put a 22 here and a 24 here. And if things are symmetric, which they are on a normal distribution, what has to go in the middle? 23, okay? And now I should be able to figure out my standard deviation, which is just itty bitty 1. So that means this is 25 and 26, and now I have everything I need for the rest of the problem. Okay? So it says, so go ahead, we do our graph, we determine the size and standard deviation. Now just answer 3 and 4. Okay? And everything after this is based on this same distribution curve. So between 21 and 25 are 1, 2, 3, 4 standard deviation total, or 2 in each direction. We just said that about 3 times already. That's 95% of your data. Again, you can do the arithmetic. It's 64 plus 27. More than 25 are just these 2 itty bitty little pieces, and that's why it's so small at only 2.5%. All the rest of the questions are going to basically use the same one. They just made it a little prettier on the next couple pages. Okay. So greater than 51. So I come back up here. Oh, that's a different problem. Okay. So mean of 45, standard deviation of 6. So let's see. Let's just make a super rough sketch here. Here we go. Here's my normal distribution. So I start at 45 and I go to 6. So 45 plus 6 is 51. So I'm looking at the one that's 13 and a half plus a couple more. Which one is 13 and a half plus a couple more? 16. 50 is way too much. That's the whole right-hand side. Okay. So 13 and a half plus 2 is 15 and a half plus the other half is going to give me 16%. Okay. This is the one. This is the same as the candy problem. Okay. So the one we just made, they just made a little prettier. You're going to use that one for everything else. The only difference is instead of percentages, we're actually tracking the actual number of packages. So you've got a package with a mean of 23. And what do you think the importance is of that? That they kind of keep the same number of candies in a package. They're trying to make money. So if they put a whole lot, they start putting in more than 26. I mean, we're talking about pennies, but if say you sell a couple million of these, well, now you're losing thousands of dollars because one person decided, oh, let's just give them a few extra. Or they just weren't paying attention on the line when the candy bag was being filled and like, okay, whatever, pushing a button. Or they don't put enough in there. You've been eating this candy for years. You know there's 23 in there, and all of a sudden there's 15? I've been gypped. Candy companies have actually been doing this for a while. Okay, so that bar when you were a little kid, that candy bar, you noticed it's smaller, and you're paying the same price. They're like, we haven't raised the price. Oh, we made the candy bar smaller. Question? Get your hand up. Nope. Yeah. Okay, so between 22 and 24, well, that's 34 and 34, so that is 68. Okay, so you're just going to spend the rest of the time. There's only a few minutes left anyway. Answer the rest of the questions. Tomorrow is a working period, which means whatever's not done, 10:01, 10:02, 10:03, gets done tomorrow. Okay, and then I'll have the review ready. Review starts tomorrow, finishes Monday, test Tuesday, or quiz, kind of like probability.
So you're here to do the homework.